Procuring IP, as you guys know, is a very difficult task. You've got your specific requirements for your application, but you probably want to use the latest process node, but there's so many options that you have in terms of the process flavor, the metal stack, the VTs, and also sort of the performance and power trade-offs you want to make for your application. And you also may want some flexibility on integration. So this can become a difficult task, especially when you need a lot of different pieces of IP for your chip. So True Circuits has you covered because we offer a full PLL DLL portfolio available in basically all IC processes available out there. We offer designs in UMC, TSMC, and global foundries from 180 micron, 180 nanometer down to 7 nanometer. And these designs are fully programmable and can be used for a wide range of applications. They are set up in a way where they're very easily retargeted for different metal stacks, VT options, oxides, whatever process flavors are available. And there's hundreds of thousands of parts available. If you check our website, you'll see. And these designs are all set up to be very easily integrated. So let me tell you a little bit about True Circuits. So we're a leading provider of high-speed analog mixed signal timing IP products. We were founded in 1998 in Los Altos, California. And we've got analog expert circuit designers, and we do leading-edge R&D in timing circuits. We use a proprietary and very powerful circuit characterization platform and automated layout generation technology to allow us to create designs in a wide range of processes and be able to support them effectively. And we also use a automated silicon characterization environment that allows us to fully test our designs and make sure that there'll be no problems. So the products that we offer are PLLs, DLLs, and DDR5s. For the PLLs, we have high multiplying clock generator, spread spectrum, and D-skew PLLs. Those are really the most general ones that are most widely used. We also have what we call a general purpose PLL, which is designed for for low area and low power and cost sensitive applications. And also our newest PLLs, which I'll talk about a little more detail later, which are the Ultra PLL and the low power IoT PLL. We offer high-speed master slave and multi-phase DLLs that are commonly used for ONFI and DDR type applications. Our DDR5 is designed to be flexible, high performance, and it's employs a lot of automated tuning and training to make it very easy to use. And as I mentioned before, all these are available in basically all the process nodes of interest, going back to 180 nanometer all the way to 7 nanometer. All of our products are designed to be very high performance and very general purpose. They're very low jitter, process tolerant. They have very wide multiplication ranges and output frequency ranges. They're designed to be small and have flexible form factors, and also they're very pin programmable. And that becomes a big advantage when you want to license one IP block and use it for many different applications. You want to be able to control it at the pin level rather than having to select a different piece of IP. And we also can do customization upon request, and all the designs are fully documented and supported through the product ramp. So our IoT PLL is a relatively new design, and it's basically optimized for low power IoT-like applications for like wearables, remote sensors. It's designed to run on the core power supply and dissipate very little power. It can support 32 kilohertz reference clocks and multiply by over 8,000 to get in the low 100 megahertz frequency range. It's designed to be small, and it's delivered as a single hard macro, that's fully integrated. And like the other designs, it's very flexible and highly programmable. So another new design that we have is the Ultra PLL, and this design is set up to basically give you everything you could possibly want in a PLL. It's set up to produce very low jitter, less than half a picosecond integrated jitter, which is sufficient for the most demanding SerDes and ADC applications. It has a very wide output frequency range from like 10 megahertz to 3.5 gigahertz, and can multiply by over 250,000, and that's enough to go from 10 kilohertz up to basically 3 gigahertz. It's a fractional N-type design. It has 26 bits of fractional resolution, so it can give you extremely high frequency accuracy. You can basically get whatever frequency you want out of it. And it also has optional spread spectrum support. So the DDR5, which is also a relatively new product of ours, is set up to basically be very easy to use. It basically uses all of our timing IP, so it's set up to have very high performance. But it uses a new architecture that basically solves all the timing issues inside the macro, rather than exposing them to the integrators to basically have to close timing at some very difficult points. And the classic problem is with any DDR5 is you've got the pins spread out around the chip to basically get the data on chip, but ultimately you want to get all the data in a relatively small area, and synchronizing all of that can be very difficult. But the DDR5 basically does that for you and provides the data with a simple synchronous interface that's has high locality. And all of the training, so the DDR5 is set up basically as a per bit architecture where it's basically doing training per bit. So it can adjust for any timing offsets that occur either on chip or on the board. And all the tuning is automated, and some of the tuning actually happens continuously. All the read data I and DQS gating are all done continuously. So as I mentioned before, it's very easy to close timing with this design, and we've set it up to be very easy to integrate in chips that have whatever I/O arrangement that they may have. With DDR, the interfaces tend to be wide, and they may wrap around 2, 3, or even 4 sides of the chip. So so we've made it very easy for you, and there's basically no assembly required. So thanks for listening, and use ChipEstimate.
My friend, John.